So let's talk chemistry with Pastor Dan. We're looking at binary ionic nomenclature. Now, before we do that, I do have a couple practice problems here to look at. So take and pause it. Try to do these just to make sure that we're back up on good speed with those. And pause it, get them done, then start the video back up. All right, here we go. So the first one, carbon trichloride, CF3. Next one, dinitrogen heptabromide, N2 nitrogen di2, hepta7 bromide bromine Br7, NO3 would be nitrogen trioxide, tri because it's 3, and then the last one there, S4I9 is tetrasulfur, known as iodide. All right, now we're going into another naming system. We're not going to use prefixes here. I'm sorry. It would be really, really nice if the fathers of chemistry, when they did, they just kept it all the same, but they didn't. So we're going to have to just make it work here. So binary ionic, the best example I can give you is NaCl, and most of you probably know the name for NaCl is sodium chloride. Now, when we look at this here, we know there are no prefixes. Okay, we don't say sodium monochloride. We don't do that. Okay, what we do is we identify the first element, sodium, second element, chlorine, and the ending is still IDE, chloride. Okay, but we have to ask ourselves a question. Do we know the oxidation of the metal, or more specifically, oxidation of the cation? Remember, that's a positively charged ion that we have there. That would be that sodium. Do we know the oxidation of sodium? If you remember the periodic chart, it's an alkali earth metal. That means it's +1. So therefore, the answer is yes. Sodium chloride, we're done. All right, so let's take a look at these. Calcium iodide, CaI2. That's calcium, and that's iodide. Do we know calcium? Yes, we do. All right, so it's calcium iodide. All right, Na2O, sodium, and then O is oxygen, so it's going to be oxide. Again, no prefixes. Do we know sodium? We just said we did. So again, all right, let's skip down. So then we have zinc, Zn3P2. I constantly want to do that. Zn is zinc, and phosphide, phosphorus. We know zinc. Zinc is +2. Or let's try when we don't know. Let's look at this one. CuF3. All right, Cu, remember we said the ones when you look at, what do you do when you see, when a thief says a copper? Cu later, so Cu is copper. And F is fluorine, so it's going to be fluoride. Do I know the oxidation number of the cation? No, I don't. So what do? We look at fluorine. If you remember the oxidation numbers, fluorine is -1. There are 3 of them. So -1 times 3, that's -3. To equal 0, copper would have to be +3. There's only 1 copper. So what number times 1 is +3? It'd be +3. So what we're going to do is we're going to do Roman numerals to represent these. Now, just in case you don't know, the numeral for 1 is I. If we have 2, just think of like on a ship, it's II. If it's 3, think you're Australian, it's III. If it's 4, you're going to the hospital and you need an IV. 5, well, I don't have one for that one, I'm sorry, it's just V. And 6 is VI. So since this is 3, 3 is right here, so it's a 3. We use parentheses around it to get it from there. All right, let's try the next one. Fe2O3. Now, if you remember the elements, Fe, where the giant say to Jack, fee, fi, fo, fum, I smell the blood of an Englishman. What element is in blood? Iron, so Fe is iron. O is oxygen, so that's going to be oxide. Now, do we know the oxidation of iron? No, we don't. So we do the same process. What's the oxidation of oxygen? The periodic chart we've done before. Oxygen is -2, but there are 3 of them. -2 times 3 is -6. To equal 0, the charges from iron has to be +6, but there are 2 of them. So what number divided by 2 divides into what 6 is what number? That would be 3. So again, that's iron 3 oxide. All right, let's try going the opposite way. This time, let's do magnesium bromide. Magnesium, symbol for magnesium, Mg. Bromide, bromine, Br. Oxidation. Well, it doesn't give me a Roman numeral there. So if it doesn't give me a Roman numeral, I must know it. Periodic chart we've done before. That's +2. Bromine, -1. Does that equal 0? Nope. So we're going to swap them down. Bromine goes to the right. Iodine's oxidation goes to the left. We don't write one, so it's MgBr2. All right, let's try the next one. Silver nitride. Symbol for silver is Ag. Nitride is N. Oxidation numbers. Silver nitride is -3. Silver is +1. Remember, sap, silver, zinc, aluminum, +1, 2, +3. Cross them down. Okay, Ag3. And now we got a Roman numeral there, so that means I don't know it. Cobalt is +3. Sulfide is -2. Swap them down. Try this one here. Try it on your own. Pause the video, see what we come up with. You probably came up with SN2O4. And you're pretty happy with yourself. But unfortunately, I would have to tell you that you're wrong. Wait a minute. Tins +4, oxygen is -2. Of course it's SN2O4. Well, here's the thing you got to remember with this. If it's a multiple, if I can simplify it down, I have to. It's required. So the answer there would be SNO2. Okay? All right. Let's try these 6. So Pb2O3, CaS, FeCl3, and they give me the formulas for magnesium oxide, silver sulfide, and platinum 2 phosphide. All right, pause it, try it. Okay, here we go. Ready? Pb2O3, that's going to be lead 3 oxide. CaS is going to be calcium sulfide. FeCl3, we don't know the oxidation of iron, but chloride is -1 times 3 is -3, so iron has to be +3. Iron 3 chloride. Magnesium oxide, magnesium +2, oxygen -2, that equals 0. So it's just MgO. Silver sulfide, silver's +1, sulfide's -2, so it's Ag2S. And then platinum 2 phosphide, platinum is Pt, phosphorus is P. It's got a Roman numeral, that means its oxidation number, not the number of platinums, is +2. Phosphide from the periodic chart is -3. It's Pt3, P2. Okay, hopefully this wasn't too bad. Take care, be good.